kinds of aggregators. For example, it is used by CEOS, Quick OpenSearch client. It is used by ESA-Fideo. It is used by EUMETSAT, the Earth Observation Portal, and also by NASA. So all these are kind of integrators which query all the same interface, and the interface is self-described, and they can aggregate then the information. The only problem in the moment was that Atom is not ideal for the latest web clients and developers, and it's not so much adopted in the moment for the mass market. And this was the reason that we also developed two extensions which are based on GeoJSON. JSON is, I guess everyone knows, it's JavaScript derived, and GeoJSON is an extension to provide the spatial information and to provide a standard set of properties as well. But the problem, and here comes now the link as well to the linked data community, is that all the elements, so the key value pairs, the keys, are not standardized. So there's no commonly agreed vocabulary, and this can then be solved by JSON LD. And the LD part then combines this keys with these URIs coming from different vocabularies, and then you have this link close to the world of linked data at this point. And it implements the 5-star spatial data on the web best practices, which are defined by the W3C. And in GeoJSON, in addition to JSON, we have GeoJSON introduces, as I said, the semantic of the properties. Every property is defined by an URI, and this defines then the vocabulary which is used by the JSON LD response format. And you have also the ID keyword, which can refer to JSON objects on a different site. And the JSON LD introduces a context which addresses the issue of a verbose document by mapping terms to IRIs. It's more or less the same concept as the namespaces in XML. You have the namespace defined, and then in the document body you only use the text with in that case in XML it's with this abbreviation, but here it directly maps the name to the namespace and closes the link to the semantic here. And the advantage is that JSON LD is directly serializable as RDF, so you can create integration clients which gather all the JSON LD documents, and then you can store it as well, for example, in a triple store, and then, you know, with the URIs you have all the semantic, and then you have these possibilities to use SparkMail, for example. And this currently discusses the next kind or next generation REST for hypermedia-driven systems, HAPTOAS abbreviation. Okay, just for information here, we are currently finishing these two specifications, one OpenSearch Earth Observation GeoJSON response encoding standard, and OGC-EO dataset metadata GeoJSON encoding standard, which adapt these things mainly by encoding the GeoJSON as a compaction through a context of the proposed JSON LD encoding. So that means that they provide just the name, and we put in the link to the JSON, to the context, and the context defines all the terms and the URIs, and this provides then the semantic. And the advantage is that a standard GeoJSON client can use this GeoJSON in a standard way, and a GeoJSON LD enabled client can also then gather the information, the links, and has also the semantic there. And what we also did, we have closed a missing vocabulary. We have defined with RDF schema the EO vocabulary, which is used in the EO dataset metadata GeoJSON encoding. The only point which is currently we are not so happy with is that the OSDD is further XML based, and this breaks a little bit the continuity with JSON, and so it's URL template. It's not structured. You have to pass the URL template, and you have limited options, especially also for the response definition, which is much better in other points. And so we're currently discussing that there is a need for a better concept for the service description, which is better aligned with web clients and developers. And this could be, for example, OpenAPI, which is currently the standard for REST APIs. It's currently out since a few weeks. The predecessor was Swagger and OpenAPI 2.0. But there are currently some points as well open, like the linking between the parameters we defined and how to get to the vocabularies there. So there are some things to discuss, but we are currently happy that we have more or less fixed the OpenSearch specification, and the next round takes another, I guess, 1 or 2 years, and if it would be not in OGC, it would be in ISO, it would take, I guess, 5 years. And so we are happy in the moment to have this OpenSearch standard. And I guess it can be used not only in the web world, it can also be used in these tabs, for example, as a standardized search interface inside these thematic exploitation platforms to get to the data, to get to the derived products, and so on. Yes, thank you.